Vivian, let's start with the basics, concrete. It's not something that is usually seen as problematic to the average person, especially in the context of climate change. Why is concrete your focus?
Because I'm focusing on construction management or construction engineering. Under the construction and demolition waste, 80% of those wastes actually come from masonry waste, and that means a lot of them are actually concrete. Give you a bit more figures to understand the details. Every year in Australia is about 22.5 million tons of C&D waste, construction and demolition waste, produced in Australia. Roughly around 5.5 million tons of concrete waste are actually generated. But unfortunately, we have all those wastes, about 5.5 million tons of concrete waste, but actually less than 5% are recycled. And less than 1% are actually recycled as concrete applications as well. That is why I like to focus on concrete, because I can see if I can reusing it properly, that actually can cover majority of those C&D waste.
And on a macro level, I suppose, if you're talking about what impact the production of concrete has on global emissions, could you tell us a little bit more about that?
Yeah, in the global perspective, the carbon dioxide emission is about 5 to 8% of the carbon dioxide emissions that actually come from cement and concrete productions. That's why you can see like majority of our activities we require to use cement and concrete for the construction activities. That's why this is about 5 to 8% of those global emissions that we are from the cement and concrete productions.
You're the co-inventor of CO2 concrete, a new process for producing durable and high-strength recycled concrete. Can you tell us about CO2 concrete and how it is a solution to the impacts we've just discussed?
Yeah, as I mentioned, because when the building crushed, they have recycled aggregate or concrete waste they produced. And that's why they crush it as a recycled aggregate. But the problem of the existing recycled aggregate is they will attach with the old cement mortar, which bringing the behavior down, the properties down, the strength down, and also the durability down as well. If we just by reusing those recycled aggregate into the recycled concrete, the strength also go down. It is roughly about 30% strength reduction with 100% recycled aggregate replacement. As I mentioned, the recycled aggregate has those cement mortar attached on the weak portion. By injecting carbon dioxide in, actually strengthen those weak parts into the strong part. That means the recycled aggregate is not like the old recycled aggregate anymore. They strengthen the old cement mortar, become like a good old aggregate. And then that's why we can reuse it any other purposes. By injecting the carbon dioxide into the recycled aggregate, the strength actually go back up. I mentioned about 30% strength reduction. The strength actually go back up with matching with the virgin concrete behavior.
Right, so there's actually no difference between the concrete that you produce, CO2 concrete produces, and virgin concrete, or the process that we know today with concrete.
Yes, that's correct.
In terms of its strength and durability.
Yes, yeah.
Okay, but how does CO2 concrete compare in terms of its carbon footprint to virgin concrete, to the production of the concrete that we usually use?
That's a big difference. That is also where the benefits come from as well. Because we are reusing the carbon dioxide and also we're reusing the concrete waste that no one wants to produce the CO2 concrete. In the life cycle carbon emission perspective, is roughly about 75% of the virgin concrete production is only required for the CO2 concrete. If we are further reducing the cement adoption, that means we're using some of the cement substitute materials, the life cycle carbon emission could be about 50% of what virgin concrete will have for the CO2 concrete.
And so walk us through how CO2 concrete is made. Where does the waste concrete come from, and where does the CO2 that it's injected with come from?
Yeah. Construction process is like that. Is you have a building, after a certain level of lifetime, you will need to demolish it, and then they will crush it, and crush it become recycled aggregate. They normally done that as a centralized recycling plants. They have their facilities to crush it as recycled aggregate, normally about 20 or 10 mil size. And once you have those recycled aggregate, normally they can be directly reusing as different purposes, but the CO2 concrete is, I will need to pre-treat the recycled aggregate. That means in the centralized recycling plants, they already have the recycled aggregate produced. What I do is I inject carbon dioxide in the process that right before they send the aggregate out. That is the pre-treatment that we have. Once we have done the pre-treatment, the rest of the process is exactly the same as what you would do for any other concrete.
So can you continually recycle CO2 concrete, or do you need to rely on virgin concrete being available in order to do what you do?
CO2 concrete can be completely recycled because the process is very simple, it's very pure as well, just really by injecting carbon dioxide. There's nothing else, nothing really tricky at all to put it into the concrete. That's why we produce the recycled concrete back to where it can be like a virgin concrete because I just purely injecting carbon dioxide in. They not only about close the loop. That means not only about you reusing the product to where it was, I can actually also bring that circular economy back. That means you can actually keep recycling it forever because there's nothing else. And unless you have different kind of chemicals in, then you may need to be a bit more concerned. But for the CO2 concrete they just can recycle forever.